mathematical analysis of amplitude modulation. Okay, so before starting this, in the previous lecture we have already discussed that the carrier wave is expressed as Vc equals to Vc sine omega c t. This is how the way we express the carrier wave. Okay, and we have discussed about the modulating signal also. Vm equals to Vm sine omega m t. So this is my modulating signal, and where Vc, we already discussed this, Vc is the amplitude of carrier signal and Vm equals to the amplitude of modulating signal. Okay, so this is the way we express both Vc and Vm. Now if we want to show it with a waveform, then how we are going to show is, because the message signal is superimposed on the carrier signal. So basically what happens is, it will take the height, it will take the amplitude of the carrier signal, and then basically I'm saying it took the amplitude of the carrier signal, and then there is my message signal here, and then this is the carrier signal here. Sorry. Okay, so this is the carrier signal here. Now this height will be Vc, and this height will be Vm, and the total height let us denote with A, which will be equal to Vc plus Vm. A equals to Vc plus Vm, right? Now if we need to write the expression for the modulated wave, so we denote it Vam. Why? Because it is the amplitude modulated wave. So we denote with the Vam, and what we can write is, Vc plus Vm sine omega mt, and here sine omega ct. Why we have written this? Because this is the carrier signal Vc, and a message signal is superimposed on the carrier signal. So basically what happens, the frequency sine omega ct is like the carrier frequency is this one, but what happens is on the carrier signal, the amplitude of the carrier signal, the whole message signal is superimposed on it. So this is the final expression of the amplitude modulated wave. Now we will simplify it. We will take Vc common. Okay, let us say this is equation 1, common in equation 1. So we can write Vam equals to, take Vc common here. So if we have taken Vc common, so it will be 1 plus Vm by Vc sine omega mt and sine omega ct. The same equation, but we have taken Vc common, right? Now can we write as Vc 1 plus m sine omega mt and sine omega ct? That means what happens is, we have denoted m Vm by Vc, and we know that what is m? M is the modulation index, and it is denoted by Vm by Vc. So this is, you need to remember it when we are doing the formula, when we are doing the numericals, we need to use this formula of modulation index, right? Now, can I write it like that? This is the final expression we get. I'm just multiplying Vc inside. So it will be Vc plus Vc multiply m multiply sine omega mt and multiply sine omega ct. And here also it will come sine omega ct. Can I just write it like this? Vc sine omega ct plus this expression, right? Now, to solve it further, we know there is a formula of sine x sine y. Half, you have already studied this formula in mathematics, x minus y minus cos x plus y. Okay, so we will use this formula in this expression. So I will write here, the first term will be same, Vc sine omega ct plus, now the second term. So I am writing Vc same, m same. Now for this sine omega mt and sine omega ct, we are using this formula. So here x will be omega m t and y will be omega c t. So I am using the formula here. So I can write half. So I can write here half cos x minus y. So I am writing the omega c minus omega m because omega c is greater than omega m, right? T minus cos omega c plus omega m t. Okay, so I have just used this formula on this one. So can I just expand the formula? So it will be Vc sine omega ct plus m Vc by 2 and cos omega c minus omega m t minus m Vc by 2 cos omega c plus omega m t, right? So this is my formula here. I'm just deleting this bracket. There is no point of using this bracket here. So these are my three terms, what I get, right? So the first, the second, and this is my third term, right? So basically, the first term is the normal component, the second term is the LSB, and the third term is the USB, right? Now, if we talk about the amplitude, here, so amplitude is basically amplitude of LSB and USB are m Vc by 2. So if there is a numerical based on the amplitude that you need to find the amplitude, you can directly use this formula m Vc by 2, right? If we need to reduce the bandwidth, we all know what is bandwidth, F USB, F high minus F low, right? Then what will happen is, what is F USB? You can see here, it is omega C minus omega M. So I can write Fc plus Fm minus, it is Fc minus Fm. So it will be Fc plus Fm minus Fc plus Fm. So Fc and Fc will be cancel out, so it will be 2 Fm, FC and FC will be cancelled out, so it will be 2 FM. So if there is a numerical based on bandwidth, you can directly use this formula, bandwidth equals to twice of FM. Okay. So we can easily now we have discussed in the previous lecture the frequency spectrum. So we can easily draw the frequency spectrum here. So this is my carrier frequency FC, and this is my USB, and this is my LSB. And USB, you can see here, for USB it is omega C plus omega m. For LSB it is omega C minus omega m. So can I write it? And the amplitude will be minus mvc by 2, and here the amplitude will be mvc by 2, and the frequency will be fc plus fm, and here it will be fc minus fm. So this is the frequency spectrum. This is the frequency spectrum of amplitude modulated wave. This is the bandwidth. We have calculated 2 FM. These are the amplitude of LSB and the USB. We have reduced from this expression, and we have expressed this expression, and this was the mathematical analysis. Now the next heading is, if we need to find out the power of this transmitted wave. How we will find out, right? So we will reduce the expression of this. We know the total transmitted power equals to power of the carrier plus P LSB plus P USB. So where I can write it, where PT equals to total transmitted power, PC equals to carrier power, PLSB equals to power of lower sideband, and PUSB equals to power of upper sidebands. Okay, and we all know the another formula we have used, M equals to Vm by Vc. So or we can write, or Vm equals to MVc. We are going to use this in the formula. Okay, and we know the deduce the waveform. Okay, so we know the amplitude modulated waveform VAM equals to, we have already reduced it, Vc sine omega Ct plus Vm by 2 cos omega C minus omega M T minus Vm by 2 cos omega C plus omega M T. Okay, I just use the previous expression, but just in place of MVC I have put the Vm here, right? Now we all know RMS value. RMS value equals to root 2. So when we need to find the power, we need to deal with the RMS value. That means divide by root 2. Divide the expression by root 2. So what will happen? Can we rewrite this expression? So it will be VAM equals to Vc by root 2 sine omega Ct plus Vm by 2 root 2 cos omega C minus omega Mt minus Vm by 2 root 2 cos omega C plus omega Mt, right? So this we have just divided it. and we all know what is power. Power equals to V square by R. So we will be talking about only the coefficients. Okay, so total power will be Vc by root 2 square. Why it's not taking? Okay, so we all know power equals to Vi. That means and I equals to V by R. So we can say power equals to V square by R. Okay, so we are just using the coefficients only, to deduce the total power. So what we will do, we will just put this V square by R in the above equation, VAM. So my final VAM will be, so VAM will be VC, you can say VC by, see this expression here, VC by root 2. So we will take VC by root 2 square, so that will be V square by R. So it will be VC by root 2 square by R. Okay, plus it will be Vm by 2 root 2 square by R plus Vm by 2 root 2 square by R. So we can write it, it will be Vc square by 2R plus, we know Vm equals to M Vc square by 8R plus we can write MVC square by 8R. Okay, that means, can I write it VC square by 2R plus M square VC square by 8R plus M square VC square by 8R. That means the RMS value, if I take Vc square by 2R common, then I will get 1 plus M square by 4 plus M square by 4. That means I will get, I can write it Vc square by 2R 1 plus, adding these two, it will be M square by 2, and I can write M square by 2 here, or I can write the total, the final formula PT equals to PC 1 plus M square by 2. So that is my final formula of the transmitted power. Okay, so where PC equals to Vc square by 2R. Okay, now if I need to find out the modulation index in form of Vmax and Vmin. So how do we find it? So there are the formulas. We know what will be my Vmax. Vmax will be equal to, obviously, carrier wave amplitude plus modulating wave amplitude. And what will be my Vmin? Vmin will be Vc minus Vmin. So adding equation 1 and 2, adding equation 1 and 2, we will get Vmax plus Vmin equals to Vc plus Vm plus Vc minus V. Okay, this is Vm here, and here also this is Vm. So my Vm is Vm cancel out, so it will be Vx plus Vmin equals to 2 VC. That means I need to find out VC will be Vmax plus Vin divided by 2. So this is the formula of VC in terms of Vmax and Vmin. Now subtracting equation 1 and 2. Subtracting equation 1 and 2. So we will get Vmax minus Vmin equals to Vc plus Vm minus Vc plus Vm. So in this case Vc and Vc cancel out and we get Vm equals to Vmax minus Vmin by 2. So this is the formula if we want to deduce Vm in terms of Vmax and Vmin. So these are some of the formulas like you need to remember for the numericals: Vm, Vc for the total power, Pt, this formula, and yes, the frequency spectrum, the bandwidth, and the amplitude of LSB and USB. So these are the formulas you need to remember for mathematical analysis of amplitude wave.